Hi there, and welcome to Wagner Academy as we continue our journey through geometry. Chapter 3, angles and parallel lines is what we're talking about today. These are the new terms for today. Make sure you know those by the end of the lesson, and if you're one of my students, use those extra examples in your book. These ones are like those, but not quite the same. So let's get started by determining what goes in these boxes here. So angle pairs with parallel lines. There's something that I'm going to make a point of over and over and over again in this lesson. You have to have parallel lines to be able to assume the things that we're going to assume are true. So notice on this picture I did not say yet that these are parallel. It looks like they are, but we can't assume that until you are told for sure. So I'm going to have you draw in an arrow here and here. Same number of arrowheads on the line, somewhere on the line itself, signifies that those two lines are parallel. Now we know they're parallel for sure, and now we can say something about the angles that match up in certain pairs. So we learned in 3.1 about transversals. This would be the transversal, and we learned about different angles, angle pairs like corresponding angles, alternate interior angles. Now we're going to say something if the angles are parallel. So assuming you have parallel lines, you can say that corresponding angles are congruent. So this is the big idea. Corresponding angles are congruent. And I'm going to use my abbreviated ways to say these things. So this is the big thing to remember there. It's important enough to circle, I think. And then we have actually 4 pairs of corresponding angles. We have 1 and 5. So I'm going to start off by writing angle 1 is congruent to angle 5. And we have 2 and 6. I'm not a big fan of how that looks. Let me make that look a little nicer. So angle 2 and angle 6, those two are congruent. Those are corresponding angles. Angle 3 and angle 7, they're both in the lower left hand portion. And finally that fourth pair, 4 and 8. So angle 4 and angle 8. Next up we have alternate interior angles, that theorem. This is a postulate because we have to assume that this is true. We can't actually prove it, but then the rest of these we can have as theorems. Postulates are generally widely accepted and widely thought of as just obvious, but depending on how you change postulates, you can actually come up with an entirely different type of geometry, all called hyperbolic geometry, which we won't learn about in this class much, if at all, but that's something you might learn in a college geometry class. But we have postulates that seem to be obvious, legitimate. Seems like 1 and 5 should be congruent to each other. Now the rest of these are theorems because based on our postulates, based on things like vertical angles and linear pairs that we learned about before, we could prove these things. So postulates you assume, theorems you can actually prove. Alternate interior angles theorem, back to the theorem now. What it says that alternate interior angles are congruent. So for instance, I'll use my highlighter for this one. I think these are a little trickier to see, not that much trickier, but 3 and 6, those are alternate interior, and 4 and 5, those are alternate interior. And so we can say angle 3 is congruent to angle 6 in this particular picture, and angle 4 is congruent to angle 5. Moving on to alternate exterior angles. So now we're not talking about things that are on the inside of the quote-unquote sandwich made by the two lines, but they're on the outside of the sandwich made by those two lines. So we have alternate exterior angles. We were going to have this one and this one, 1 and 8, and we're going to have 7 and 2. So let's write those down, and let's write that alternate exterior angles are also congruent. If you look at the picture for these three, it seems like that should make sense, I would say. So 1, this is an obtuse angle, this is an obtuse angle down here, angle 8. These two match up. 2 and 7, those are acute and acute, those two match up. And we're not proving these theorems in this lesson or in this video, but there are plenty of valid proofs or ways you can see how it's proved out there. We have, I think one of the theorems is proved in our book if you're one of my students, but if you wanted to see a proof of that, you could go check it out. Plenty of other videos or explanations out there about that. We're just going to take these things kind of for granted. Theorem 3.2, back to this we had. That was 1 and 8. I didn't mean to erase that already, but that's okay. 1 and 8 and 2 and 7 are congruent to each other. And then I purposely put CIA, consecutive interior angles, down here at the bottom because this one's kind of sneaky. This one is not the same as these ones. These are all congruent, congruent, congruent. This one, CIA, these are supplementary. They add, in other words, to 180 degrees. So you could write CIA are supplementary. I chose to write CIA add to 180 degrees because it was shorter to write. That's the only reason why. So I could have, in this picture, I would have 4 and 6 would be consecutive interior, and 3 and 5 would be consecutive interior. So I could say that 3 plus 5, not just the angles, but the measure of the angles. So that's important to include in there. Make sure you get the little m's in front of there. That would equal 180 degrees. And the measure of angle 4 plus the measure of angle 6 would also be 180 degrees. Remember that angles can be congruent to each other, but angles can't equal a number. Measure of angles can equal a number. All right, let's move on to our next slide. And example 1. In the picture below, blank and blank. So some things are true in this picture. I'm going to tell you this looks like a script L, M, and this is a T. T is representing my transversal here. I'm going to tell you that this is true. So I told you I would hit this over and over again. Here it is. We can't assume just because they look like they're parallel that they are. We have to actually be told that we can assume that, or we would have to prove it somehow that they are parallel. So I'm going to tell you that you can assume that M and L are parallel, and I'm also going to tell you that the measure of angle 1, there we go, I think I was pressing a button there, my pen wasn't working for a second, there we go. The measure of angle 1 is going to be 60 degrees. So here's 60 degrees right here. So as we fill this out, and I was thinking about writing in measure of angle 1, measure of angle 2, but I wanted you to get that in your head that you need to have the little m in front of the angle if you're technically going to be right about this. It's the measure of the angle is equal to a number, not the angle itself. So I'm writing this for measure of angle and then every single angle that we have in the picture. So we've got 8 angles. So this might seem daunting at first. Don't worry about it. You're going to be okay. If you have a different color, this is a great time to use that. For this whole lesson, the rest of this lesson, there's going to be times where I'll put stuff in the normal color in the pencil like you should be using. And then the extra stuff that I add in addition, or as I prove things about it, I'm going to add that in a different color here. So I could say, for instance, well, I could say I'm given angle 1. So let's start with that, 60 degrees, and this is given to me. That's my justification for angle 1. So let's look at angle 2 now. 1 and 2, these are parallel lines based on the corresponding angles postulate. I know corresponding angles are congruent if the lines are parallel. And so this one and this one would have to be the same thing. So I could say then, I'm using my different color now, that one would also have to be 60. And my reason for that, based on angle 1 being 60, these are corresponding angles. So I could say this is corresponding angles with angle 1. From there, let's see what else I could say. It looks like I'm going to try to come up with as many different reasons as I can. You actually could use a lot of the same reasons over and over and over again, but I'm going to try to use as many different ones as I can just so we get used to seeing different things. So let's go with angle 3. Let's just go in order for now. I might jump around a little later, but based on what I have in the picture, I can see 1 and 3 would form a linear pair. So that would have to be 120 degrees. It's just 180 minus 60. So this one, 120 degrees. And my justification for that, I could say a linear pair. It's happening again. Linear pair, there we go. Stop pressing the button, Mr. Wagner. Linear pair with angle 1. Okay, so now angle 4. Let's see what we have for that. It looks like those would be the same old justifications. I could use corresponding angles with 3 and 4. I could use a linear pair with 2 and 4. So I'm going to skip that one for now and make it a little more interesting. I'm going to go to 5 instead. So I noticed 2 and 5. This would be a new justification. Just for kicks, I'm going to use a new justification here. 2 and 5 are what kinds of angles? You said it, I hope. Consecutive interior angles. So this one would have to add with this one to get 180. That means angle 5 would have to be 120. So I'm going to skip down to here. I'm going to say that this was CIA, consecutive interior angles, with angle 2 there. Angle 6, I see a new justification I could use, and again, you wouldn't have to use these different justifications. I'm just trying to get practice with all of them. So 120 degrees, I could say that. That would be a linear pair here, corresponding with 5 and 6. That would also work. But a new justification would be 3 and 6, our alternate exterior angles. So why don't we go with that as our justification? 120 degrees. This is alternate exterior angles with angle 3. And let's see here. Angle 4 now. Since I know angle 5, I'm going to use alternate interior angles to justify the reason that angle 4 would also have a measure of 120 degrees. So I can put that in there. And now I'm going to say 120 because of a IA with angle 5. That was okay. And let's see, have I used all the different types? I've got one other type that maybe you're not thinking of. Do you remember another one that I didn't include here yet? How about 1 and 7? What kinds of angles are those? If you said vertical angles, you are correct. That's 60 degrees because that one's 60 degrees. That would be a valid justification. So we could say that. And again, lots of other valid justifications, valid reasons why you could say these things. But I'm going to go with vertical angles there with angle 1. And then I think that's all the different possibilities. We had linear pair and vertical from previous chapters, and then we had these 4 new ones from this chapter. So I'm going to just go with, I'll say a linear pair again with angle 6. I could say angle 4 if I wanted to, but I'll go with 6. So a linear pair with angle 6 would work. And then this other theorem, the final theorem that we have in this lesson, theorem 3.4, is the perpendicular transversal theorem. And it's really the corresponding angles postulate in disguise, because you have parallel lines here. If this one's perpendicular, this one and this one are corresponding, so that would make that one perpendicular as well. So I added that in a different color. This is something that we can prove is true based on what we know from before. So it states that if a line is perpendicular to one of 2 parallel lines, that would be, these are your 2 parallel lines. This line, the transversal, is perpendicular to one of those 2. That means it also has to be perpendicular to the other. So then it is perpendicular to the other. And a football field is a good example, I think, of that. You've got all these lines on the football field that are parallel to each other, and I can't draw. Let's try that again. So this line, this line, this line, these are all parallel to each other. And if one of them is perpendicular to the sideline, that would mean the rest of them are perpendicular to the sideline based on this theorem right there. All right, let's talk about example 2 now. What is the measure of angle RIU? So looking at the picture, I don't think it's very clear what that's going to be initially. So we got RIU. It's kind of in the middle of these lines. Are these lines parallel? Well, we can't assume that based on the information in the picture. However, I'm going to have you add this in your normal color that yes, in fact, you can assume this. So add that in. I'm going to just tell you that we can assume that's true because I told you so, basically. We didn't prove it. I'm saying this is given to us. This is given information. What could we do to figure out this? So this is meant to lead us, the letters here, into thinking about an auxiliary line. And so we're going to add an auxiliary line to this picture. That's just an extra line to help us make sense of what we have here. So I'm going to add a line right here in the picture. And this is an auxiliary Coast Guard serviceman. That means he's providing extra help when the Coast Guard needs backup. In come the auxiliary forces. So we have this line, and we can assume that it is possible to draw a line in between any two parallel lines that is also parallel to those two lines. So I'm going to have this auxiliary line. I'll fill these arrowheads in. Don't have to do that, but I'll fill them in just because the rest of these are filled in. So now we have these three lines being parallel to each other. Because I've done that here, well, let me label this first. So how do you spell auxiliary? It's spelled like that. So this is an auxiliary line. It's an additional line made to help us figure out the problem. So we have 50 degrees here. Because that's 50 degrees, I could also assume, based on, I have parallel lines here, this would be corresponding to this angle. So I could add this in. I'll use my different color for that. I could add that into the picture. I could say that would have to be 50 degrees as well. And based on what else I have here, if I know this is 140, then I would know, because of a linear pair, this one would have to be 40 degrees. And if that one's 40 degrees, this one would have to be 40 degrees. I also could have said that because this one's 140 and these two angles are CIA, are consecutive interior angles, I could have gone straight to that and just said that was 40. So a couple different ways we could go about showing what that is. And now that we have these two angles, that's what I'm looking for. I'm looking for RIU. I can just put those two things together to get my answer. So a recap of what was just said there, the measure of angle cry. Well, where's a C? I need to put an auxiliary point actually in here. So I'm going to add that in and call that C. Otherwise, I don't have any way to label this angle. So angle cry, I'm going to say, is what that's called. That could be 40 degrees, or that would be 40 degrees. And my reason for that would be that was a linear pair. So I could use that if I had to as a justification. I'm not saying I had to do that here. That's why I'm using that different color. So it's extra information there. I could say the measure of angle, well, this angle, based on what I just said there, would be 40 degrees, but I would need a point over here to be able to name that angle. So I'm going to call that point B right there. So that would give me, the measure of angle rib. So the measure of angle rib would be 40 degrees as well. That would be corresponding angles. Or again, you could have said consecutive interior with angle R, with angle IRY. That would work as well. And then we can say angle UIB, the measure of that one, is equal to 50 degrees based on corresponding angles as well. And that information put together gives us our conclusion, what we need to figure out in the first place. What's the measure? Notice I wrote the word measure of in front of the angle. That's why that was okay. But if I write a little m in front of the angle, it does the same thing for me. So a measure of RIU would be 50 plus 40, which is going to equal 90 degrees. So I had a lot of extra space on that one that I didn't actually need to use. But 90 degrees, does that look like it's exactly 90 degrees? Not exactly. Again, that's why we can't trust how the picture looks. We have to trust the information that's given in the picture. And our final example Well, look who it is. Look who's making his return. It's Fire Marshal Bill. How you doing, Fire Marshal Bill?
Hey kids, how you doing? I'm doing fine. Here to help you learn some geometry.
Fire Marshal Bill, would you do the honors of reading this question for us?
Why, certainly. Solve for x and y, then determine the measure of angle FRE.
Thanks, Fire Marshal Bill. All right. Might call upon your help in a little bit. Again, let's see. Well, we've got this angle, this angle. We've got these lines here. I don't see any parallel markings on here. Yeah, I know. I told you I'm going to be harping on this over and over and over again. Can we assume these are parallel just because they look like it? Nope. Can we assume they are parallel if I tell you that you can assume they're parallel? Yes. So I'm giving you this information. We would need to know this to be able to figure this problem out. I'm going to tell you that in fact these are parallel. So notice I'm putting one arrowhead here and here. These two are parallel. But if I just put one arrowhead here, that would mean this one is a parallel to this one. Clearly not true. They cross right here. So I have to use a different number of markings, just like I do with segment tick marks and angle arc marks. I use a different number of arrows to designate that different pairs of lines are parallel to each other. So this one parallel to this one. Based on that information, it looks like I could say 3x plus 10 would equal 5y plus 5, but that would have two variables in just one equation. There's no way I could figure out what x or y are from there. However, I see 4x minus 15, 3x plus 10. These are with respect to these two parallel lines and this transversal. These are alternate exterior angles. They're on the exterior of these two parallel lines on alternate sides of the transversal. So I'm going to add this into the picture. I can say that this is congruent to this. So great. What's that mean in terms of an equation? We have 3x plus 10 would equal 4x plus 15. And if you had to give a reason for that, you could say alternate exterior angles. From there, you can solve both sides. You can solve for x, subtract 3x from both sides, and then I would have to subtract 15 from the other side. And I just caught a mistake that I made there. This should be a minus sign. That's why that wasn't making sense to me for a moment there. So I should add 15 to both sides. That's 4x minus 15 there. So add 15 to both sides. This goes away. I've got 25 here. And I've got an x. That is a crazy looking 5. Fives are not my best number. I don't know if you've noticed that. Fives, for me, I'm just not that good at making fives unless I really take my time. So 25 equals x. That's one of the things I needed to know. Solve for x. So now that I know x, now I could use that thought I had before. 3x plus 10 equals 5x, or 5y plus 5. I can use that equation. So I'm going to write that down. 3x plus 10 equals 5y plus 5. So many fives. All right, and I've got it's my nemesis, the 5. So I've got Perry the Platypus, my nemesis. Oh my gosh, what the heck? What is Dr. Doofenshmirtz doing here? We have this would be true based on corresponding angles. So we have subtracting. Again, this is in terms of two variables, so how do I figure this out? Well, look at this. You just figured that out. 25 was x. So now I can just plug that in for x and solve for y from there. So we have 75 plus 10. That's 85. And 5y plus 5. Solve that for y. Subtract 5 from both sides first. That goes away. You're left with 80 equals 5y. And if you divide both sides by 5, it'll give you your answer, your solution for y. That would mean 16 equals y. So we could have actually added in the picture, we could have added this as well. I know that this and this one will be congruent. Since this one's congruent to this one and this one's congruent to this one, You could also say that this angle would be congruent to that angle. So notice they all have the same number of arc marks. That's because they are all congruent. So based on that, now let's find the measure of angle. Fire Marshal Bill, which angle are we looking for again?
Angle FRE. There's the angle you're looking for. Let me show you something.
Thank you, Fire Marshal Bill. Let me show you something. We're going to have the measure of angle FRE plus, looking at this picture, that's this angle right here. So I'm looking at this one. Let me highlight that. I'll go with red for the highlighting there. So I'm looking at this angle right here. What's the measure of that angle? Well, I know that this one plus this one would be 180. These two lines are parallel to each other. Consecutive interior angles would have to be supplementary. So I'm going to use that to make an equation. FRE plus 4x plus 15 and 4x minus 15, excuse me, don't want to make that mistake again, equals 180. Now I can solve this for FRE, the measure of angle FRE. I know what x is, so I'm going to plug that in. And I didn't have to use parentheses here, I just chose to. So I've got 4 times 25 minus 15 equals 180. That means the measure of angle FRE. And this would be 100 minus 15. That would be 85. So that has to be true. And I forgot my justification there in case you had to say it. This was because of CIA, that sneaky one that adds to 180 instead of being congruent. So we can, final step, subtract 85 from both sides. The 85s will cancel, and I'm left with what I'm looking for, the measure of angle FRE equals 95 degrees. And again, notice in the picture it doesn't look like it's quite 95. It looks like, I would say it looks like it's a little bit bigger than that, but pretty close to that. So again, don't trust the picture, trust the information in the picture. So you can also check your answers by plugging these numbers back in. I think that's valuable to do quickly here. So if I plugged in 95 plus, this would be 85, that would be 180. If I plug in 25, I would have 85 on this side, I would have 85 on that side. If I plugged in 16, this would be 48 plus 10, that would be 58 there. I'm sorry, I meant to say 3 times 25, that would be 75, plus 10 would be 85, and then 5 times 16, that's y, not, this one was not, so this was 5 times 16, that's 80 plus 5, also 85. So that checks out. So that's our final example for this lesson. Make sure you review as needed. Go back, check these terms out, make sure you understand those. If you don't, review the video, ask me questions, comment. I hope you have a great day as always, and I'll see you for our next lesson, 3.3.